Good morning. The work we're going to do today is carrying on with our work with cubes and cuboids, but today we are going to look at solving problems with cubes and cuboids. So our driving question today is, how do we solve problems with cubes and cuboids? Now, the work today is such that you're going to need a calculator. So I suggest, if you haven't already got one to hand, when you stop the video to answer these questions, the first thing you do is go and get yourself a calculator. Okay, these first questions are just working out volumes of cubes and cuboids. So stop the video now, go get yourself a calculator, or if you've got one already, just start and answer them. As soon as you've done them all, turn the video back on and you'll see me go through the answers. Right, sorry about that, but here we go. So for question A, our first question, what we need to do, just like yesterday, we start with our formula. The volume equals the length cubed because it's a cuboid, so the volume is going to equal 6 cubed. 6 times 6 times 6, which is 6 cubed, is 216 cubic centimeters. Remember, you've got to write cubic centimeters. It's a very important part of the answer. Make certain that you've done it. Part B, the cuboid. The volume of a cuboid is length times width times height. So in this case, the volume is going to be 18 times 6 times 6. If you've written those three numbers in any other order, it doesn't matter. So the volume is 648 cubic centimeters. Now, once I've done those, I can actually make up for C and D. I can use those volumes to find the answer. So, for example, the horseshoe shape in C can be made up of 1B, which is going to be 648, and 2 A's, and each A is 216. So if I multiply those two numbers, if I multiply 216 by 2, I get 432. And if I add those together, 0, 8, 0, 1, I get 1080. And since these are both cubic centimeters, the answer must be cubic centimeters as well. And my last one, very, very similar. I have 4 lots of shape A, so that's 4 times 216, which is 832, and 1 of shape B. I know you can't see it, but it is just 1 of shape B. So that again would be 600. Sorry, my mistake. That's 864, and this is 648. If I add those numbers together, so 4 and 8 is 12, put down a 2, carry the 1. 6 and 4 is 10, and 1 is 11, put down the 1, carry the 1. 8 and 6 is 14, and 1 is 15. 1,512 cubic centimeters. And that gives us the answers to our first question, or our first questions. Hope you got all those correct. If you're a little uncertain, if you've had you found this really, really difficult, I suggest you stop this video now, go back to the previous one, work through it again, make certain you understand how to find the volumes of cubes and cuboids. Okay, let's have a look at our next question. Now, this first question we need to just look at and study for a minute. We've got this rather strange L-shaped shape. It's not a cuboid, nor is it a cube. But if we look carefully, we can see that it's actually made up of cubes, or cuboids rather. So the first thing that we're going to do is we're going to divide this shape up. The way that I've chosen to do it is to slice it across here. If I slice this piece, basically the top, straight off it, I get these two shapes, here and here. The way that we're going to work these out is to actually just find the volume of this cuboid, find the volume of this cuboid, and add them together. That plus sign there is there for a reason. So let's have a look and see how we actually do that. Right, I've drawn one of these early just to show you. And the first thing we need to think about with this particular shape is that, as you know, with cuboids, we need 3 numbers. But on this shape, we haven't been given 3 numbers. We've got 3 numbers here. That's fine. But we've only got 2 numbers here. So we need to look back at our first shape and see if we can work out what this number is going to be. Now this number, because this shape fits exactly here, and this side here must be the same length as this one, I know that this side is actually 4 centimeters. Now I've got my 3 sets of numbers for each cuboid, and I can work out the area of each. For the purpose of making my calculations clear, I'm going to call this one shape 1 and this one shape 2. So for shape 1, I must multiply 6 by 4 by 2. Well, 6 times 4 is 24, times 2 is 48. For my next shape, I have 10 for shape 2. I have 10 times 4 times 3. 10 times 4 is 40. 3 40s are 120. Because 3 4s are 12, and I've got to multiply that by 10. So that gives me 120. If I add those two numbers together, I get 168 cubic centimeters. Remember, if the length measurements are in centimeters, the volume measurement is in cubic centimeters. Okay, so what I suggest you do now is pause the tape and work your way through this question. You may want to draw everything on the PowerPoint slide there before working it out, just so that you understand exactly what's going on. But I do think you need to write this down before you go any further. So pause the video, write this down, and then we'll be ready to move on. So here's a chance for you to do your own work. We have 2 cuboids, both of them L shapes. So both of them need to be divided up, and then for you to work out the volume of the combined shapes. Notice with the second one, 14b, that you are actually missing one of the measurements. You're going to have to calculate that yourself. If you look carefully at the shape, there is enough information for you to work it out, and we shall be returning to that in a moment. Okay, pause the video, have a go at these shapes yourself. So, let's see how we did. Question, we call it A, so 14A. We have to divide up into two shapes. What I'm going to do here is just do a very quick dimension or a very quick drawing of what the end of the shape would look like, the L shape, just to show you how I would divide up that shape. We've got this L shape here. I know this isn't drawn to scale and I'm using the lines, but that's okay because I'm going to put measurements on and I know certain of these measurements. I know that this is 3. I know that this is 6. I know that this is 8. I know that this is 4. And that's all. Oh, sorry. And I do actually know that this one is 2. So what I'm going to choose to do in this case is divide my shape, just like the last one. I'm going to slice it across here. So I don't know why I wrote 18 there. That's wrong. I should have written 8. So I'm going to divide this into two cuboids like that and multiply them together. I know I haven't drawn them as cuboids and I've missed off one of the dimensions, but that's just so that I can do it nice and quickly. So shape 1, shape 2. So again, we don't get confused. So the dimensions for shape 1 are 3 times 2, and this is the dimension that I was missing, times 5. 3 times 2 is 6, times 5 is 30. And the bottom shape, I know this is 4, so 8 times 4 times 5. And I can work this one out as well. I'm going to work this one going back the other way, so it's easier for me to do. 5 times 4 is 20, times 8 is 160. And now, as before, these two numbers need to be added together to give me a total of 190 watts. But in this case, again, it's cubic centimeters. So lastly, on this question, let's look at 14b. I'm going to start with another little drawing. It's going to look exactly the same because I don't need to do anything more. I've got my L shape yet again. And I know that this one across the top is 2. I know that this one going all the way down here is 5. I know that this one on the bottom is 5. And I know that this one up here is 2. I don't know this dimension here. Now I do know that from here to here is 5, and from here to here is 2. So from here to here, it must be what's left after you take 2 away from 5. 5 take away 2 is 3. So I know that this side here is 3. Once again, I'm going to slice it this way. Call this one shape 1, this one shape 2. And now I can work them out. If you didn't get 3 for this, pause the tape here, rewind it and go over my answer again. Make certain that you understand why this is 3. So shape 1, we've got 2 times 2 times 4. 2 times 2 is 4 times 4 is 16. And on the bottom, we've got 5 times 3 times 4. 5 times 4 is 20. 20 times 3 is 60. Obviously, you can do that lots of different ways. There's at least three, well, there's 3 different ways of working at that. And that was the easiest one for me to do. Sorry, that was my phone. So, adding these together, I get 76. I look again, what's the unit this time? This time it's meters. So it's 76 cubic meters. So this is a much, much bigger volume. 190 than the last one. 190 square centimeters is nothing like the size of 190 cubic centimeters is nothing like the size of 76 cubic meters. This is a much, much bigger thing altogether, even though the numbers don't look that much different. Okay, once we've done that, let's move on to our next question. Our next slide. There. Now, here we've got a very, very peculiar looking shape. But if we look at it seriously for a few seconds, we can see that what this is 2 cuboids put one on top of the other, but one of them is at 90 degrees, so it's been spun round. It's like putting together 2 Lego bricks to make a corner. They're still 2 cuboids, they're just not in the same plane, but that doesn't make any difference to what we're about to do. So, armed with that, I'd like you to have a go at working out the volume of this shape. Pause the tape, and when you've answered it, put it back on and check the answer. Okay, so with this shape, I'm not going to draw this. Actually, I am going to draw this, but I'm still only going to draw it as 2 dimensions rather. So the L shape again. Imagine that we're looking at the end. We're looking at it side on, and it would look like this. The reason why I'm drawing this is just to show you where we get all our dimensions from. Once again, I'm going to divide it up that way, but we'll come on to what that's going to tell me in a minute. So I know that this is 10. I know that this is 5. I don't know what this is. I don't know what this is. I know that this is 7. And I know that this is 3. So, we don't seem to know too much about this shape, but let's have a look and see what we can find out. So, I know that this dimension, from here to here, must be the difference between 5, or it must be 5 take away 3, because here to here is 5, this is 3, this must be what's left, so this must be 2. In the same way, if here to here is 10, and here to here is 7, this must be what's left. And 10 take away 7 is 3. Now we've got that, we've got enough information to do our volume calculation again. So shape 1 is 3 times 2 times 5. 3 times 2 is 6 times 5 is 30. And 2 is 10 times 3 times 2. 10 times 3 is 30, times 2 is 60. If I add those two numbers together, I get 90. And the units are centimeters, so this will be cubic centimeters. Okay, pause this for a second if that's not what you've got, and go back over it. Other than that, once we start, we're ready to move on to our next question. The diagram shows the dimensions of a water tank. Alex puts water in the tank so that it is 3/4 full. What is the volume of water in the tank? So as well as finding the volume of the tank, we've actually got to find out a fractional quantity of that volume as well. So there's a fair amount of work in this, but nothing that we can't do, especially with a calculator. This is a question that really does need a calculator. So when you're ready to start, pause the video, and when you've finished doing the question, put the video back on and we'll go through the answers. Okay, I don't really think there is a lot of point in drawing this question. So the volume is length times width times height, as we've said a lot. So in this case, we have got 76 times 52 times 56, which gives us a total of 221,312. Notice I haven't put in a comma, but I have left a gap between the hundreds and the thousands. And that's the way we should be doing it. Now, how do I find 3/4 of a number? Well, in this case, I'm going to need a calculator, because what I'm going to do is I'm going to multiply this number by 3 and divide by 4. So the 3 is the numerator, the top number of the fraction. The 4 is the denominator. So the first thing I'm going to do is do 221,312 times 3, which gives me 663,936. Now it's a bit too much of a gap, but never mind. Now I'm going to take that number, 663,936, and divide that by 4. If I do that, I get 165,984. And what's the unit? We must always remember the unit. In this case, it's cubic centimeters. And that's my answer. It's quite a big number, but with the calculator, that shouldn't be posing too many problems. Okay, if you need to go through that again, pause the tape, run through it. Otherwise, we'll move on. The diagram shows the dimensions of a dice. A box has dimensions 12 centimeters by 10 centimeters by 8 centimeters. How many dice will the box hold? And there's a really good hint. Sketch the box. Start by working out how many dice will fit along the length of the box. Well, yeah, that's a really good idea. So when we come back, I'm going to show you how I work this one out. So pause the tape, answer the question, and come back when you're ready. Okay, let's start with a very, very quick sketch of this box. So we've got a box. I did say it was a very quick sketch of a box, and I've made a slight mistake, but it doesn't matter, it's just a sketch. So I've got 12 centimeters by 10 centimeters by 8 centimeters. I'm going to write those down. 12, 10, 8. How many dice can I fit along this side? Well, each dice is 6 centimeters. Each dice is 2 centimeters wide. So I've got 12. 12 divided by 2 is 6. So I could fit, oops, I've messed this up, 6 dice along here. Here to here is 10 centimeters. Each dice is 5 centimeters long. How many could I fit in along here? Well, 10 divided by 2 is 5, so I've got 5 dice. And lastly, 8 centimeters. How many dice could I fit in 8 centimeters? I could fit in 4. So this is going to be 4 dice. So what I'm saying in this case is on the bottom I would have 6 dice by 5 dice in one layer, and I would have 4 layers. So my total would be 6 times 5 times 4. 6 times 5 is 30, times 4 is 120. 120 what? Well, in this case, it would be 120 dice. If you didn't understand that, pause the tape, give it another go, and when you're ready, come back and join us for the next question. Right. Each box of Archie sweets needs to hold 50 cubic centimeters of sweets. Here are 3 designs for the box. You have 3 designs. Which design do you think is the most suitable, and why? Work out the side length to 1 decimal place of a cube-shaped box that has the correct volume. Work out the dimension of 2 more boxes with a volume of 50 cubic centimeters. So we've got 3 different questions there. This is quite a complicated question, but it starts off quite nice and easy. You've got to work out the volume of 3 different cuboids. So have a think about it. Stop the tape. Think about, for question B, think about what's the opposite of squared. So what would be the opposite of cubed? So what would you do to get back to the number you started from? So give it a go, and you should definitely be able to do part C. Give it a go, turn the tape back on, and you can check out how I would do it. So let's start with the relatively easy part. Shape A. So this is question A. So yeah, so shape A, our volume is going to be 4 times 2 times 6. 4 times 2 is 8. 8 times 6, 6 eighths are 48 cubic centimeters. That's too small. shape B, we have 3 times 3 times 8.2, which gives me 73.8 cubic centimeters. And that is too big. Part C gives me 5 times 3 times 4, which is 60 cubic centimeters, which is also really too big, but only just. So it says, which one is the most suitable? I would say C is most suitable, because it is bigger than 50 cubic centimeters, but not too big. There's not as much wasted space in B as there would be in C. So now the next one, part B. Work out to the side length to 1 decimal place of a cube-shaped box that has the correct volume. Now, to find, if we know the area of a square, we find the length of the square by finding the square root. Yeah, so if we've got a square that has an area of 16 square centimeters, we find the length of the side by finding the square root of 16. And we know that the square root of 16 is 4. When we do this, when we're finding the length of a side of a cube, we actually find the cube root. Now, the cube root of a number is a sign that looks very, very similar to a square root. Hold on, let me just increase the size a little bit. It's very similar to a square root, so the square root of 50. But to differentiate, I write a small 3 here. In the same way as when we're doing cube roots, we write a small, cubic centimeters, we write a small 3 after centimeters. When we're finding cube roots, we write a small 3 near the root sign. So what I'm trying to find now is the cube root of 50. Now, without a calculator, this is quite a difficult calculation to do. I do understand that. But with a calculator, it's quite simple because there is a button that looks like that. So you press that button and then you type cube root straight after it. And if you do that, you get a number that starts 3.684 and carries on for the rest of the display of your calculator. Now, in this particular instance, the question says find the answer to 1 decimal place. So I only need to write 1 decimal place. In that instance, 1 decimal place is going to be, well, 1 decimal place here looks like the 6. I then look at my next number, which is an 8. 8 is more than 5, so I've got to add 1 to the 6. So my answer in this case would be 3.7 centimeters. Okay, because I'm going from a volume back to a length. So if I made a box 3.7, if I made a cube 3.7 centimeters aside, I would have an area of very, very close to 50 volume, of very, very close to 50 cubic centimeters. It would be a little bit big, but not really very much. So that's how we find it. We use the cube root. Now the last question. Come up with two boxes. You have to pardon me for changing over page, but still. Come up with the volume of the volume of some shapes, or come up with the dimensions of other shapes for the volume of 50 cubic centimeters. Right, okay. So let's start thinking of ways of doing this. What I could do is say, okay, how do I make 50? Right, the easiest way of making 50, the first thing that came into my head was 5 times 10. So if I multiply 5 by 10, I make 50. Is there two numbers I can multiply together to make 5? Sort of, but I'm not going to do that yet. Is there a way of making 10? Yes, there is a way of making 10. I can do 5 times 2. So one way of making 50 would be 5 times 5 times 2. So those could be the dimensions of my box. I could do 5 centimeters times 5 centimeters times 2 centimeters. Another way I could do it is by thinking to myself, right, okay, let's set one of those dimensions at 1. So if one of my dimensions is at 1, the height of the box is 1, I've got to do 1 times 2 numbers that make 50. Well, 2 numbers that make 50 is 5 times 10. So that would also equal 50. So there are 2. There are other ways of doing it as well, but you are going to need to use decimal numbers, because these are all prime numbers. So the only way you can, if you want to make one of these smaller, you have to make fractions. What I could do is, if I half this, I have to double one of the others, and the one I'm going to double is the 2, which will give me 4. So that gives me 2.5 times 5 times 4. 4 times 5 is 20. Twice times 20 is 40. Half of 20 is 10. 40 add 10 makes 50. And there are lots of other ways of doing it as well. If you found other ways of doing it and it works on a calculator, that's absolutely fine. But there's 3 suggestions for you. With this question, there are more right answers than that. I know that. So if you've got one that works, but it's not one of the ones I've written down, that's absolutely fine. Okay. Once again, if you're a little uncertain, pause the video now, come back to it, and come back when you've gone through it again. Okay. Right, we've now reached the last question in this topic. I'm not going to give you the answers to this one, because this one is something that I just want you to think about. Maths is not the only subject that uses volume. I can think of lots. You use it in science too. Describe when you might have used volume in science. So think about your science lessons. What have you ever measured that might need volume? I can think of a few. In which ways is volume the same or different in science as in this math lesson? And what do you think volume means? Do you think volume means the same in all subjects? So are there subjects that use the words volume but don't mean what we've just said? I can think of one, but have a think. See if you can come up with something. Okay, that's the end of this video. I hope you've learned something, and I hope this is going to help you when you do your quizzes a little bit later on in the week. So now you've done, you can now stop. Maths has ended.